Hello, everybody. Welcome to SBI Health and Safety and Bulwarks webinar. Are you really protected from electric arcs? My name is Amélie Leduc. I'm a marketing advisor here at SBI. For those who don't know SBI, our mission is to be the single most valuable partner for companies that value health and safety in their work environment. And how do we do this? By providing training and expertise and also selling personal protective equipment in one of the risk categories you see on your screen. I have the privilege to be accompanied by Tara Siegel. Hi, Tara. How are you?
Hi, Emily. I'm good. Thank you for having me.
Good. Thanks for coming. Tara, you work at VF Imageware. You've been working there for more than 10 years, promoting the Bulwark brand.
Yes, exactly. So mainly I take care of Quebec and I represent Bulwark, which is our FR and Arc Flash clothing line.
Good. So, how is it going to work today? The webinar is going to last 30 minutes. You do have a question box on your console where you can chat directly with us, ask your questions. Don't wait till the question period at the end. If we can answer as we go along, we will. And to make sure it all works for everybody, please type in the question box which city and province you're from. That would be great to know where our audience is coming from. We're going to have one interactive question today for you. And as usual, for the ones who have participated in our previous webinars, we do have our famous survey at the end, which we would really appreciate if you could take some time to answer it. So we have Amanda from Kamloops, BC. Hi, Amanda. We have Jose from Ottawa, Ontario. Hi, Jose. We have Robert from Manitoba. We have here Edmonton, again Ontario. We have from Quebec. We have Surrey, BC. So good. I guess you guys have found the question box. Now you're all set to ask your questions as we go along the webinar today. So today's theme is arc flash protection. So we're going to discuss with Tara, we're going to discuss about arc flash protection, sorry. So there are many risks of injuries that are related, Tara, to electrical arcs and explosions. It can range from superficial burns to workers' death, unfortunately. So it's essential to wear AF clothing when there's a risk of electric arcing. So today we're going to look at different fibers that protect against the risk of electric arc, sorry. We'll talk also about arc ratings in order to ensure the compliance and safety of your protective clothing. And finally, we'll talk about what makes up an arc rating and finally address what the CSA Z462 standard really requires. So without further ado, let's start with some definitions, maybe just to set people so people really understand the terms you're going to be using throughout the presentation.
Perfect. So these are a few definitions that you likely come across when talking about PPE or protective clothing. I don't want to read through all of them, but today we'll be focusing mostly on the term flame resistant, which means a fabric that will self-extinguish, which doesn't melt, drip, or add to the injury of the wearer. Then we have arc rated garments, which are tested to the electric arc flash hazard. And then we have the abbreviations, which I will be using mostly during this presentation. So FR, of course, is flame resistant, AR, arc rated garments. So also note all arc rated garments are FR, but not all FR garments are arc rated.
And we'll demystify that as we go along.
Correct.
The upcoming slides. So let's start with flame resistant fabrics, Tara.
So well, we know there's many different fabrics in the flame resistant world that can protect us against electrical arc hazards. So mainly we like to think of them separated into two groups, which are inherent fabrics and treated fabrics. So we're going to explore these categories in the next few slides and discuss what the advantages and disadvantages are.
Good. So there's some confusion in terms of the comprehension of those two terms. So what do they actually mean, Tara, when talking about inherent or treated?
So when we look at an inherent fabric, we're talking about a fabric where the FR chemistry is built into the polymer of the fiber. So meaning the chemistry is done at the molecular fiber level. Treated fabrics are where the FR chemistry is applied to the actual fabric and not the fibers. Now it's important to note that neither inherent fabrics nor treated fabrics is better than the other. There's advantages and disadvantages to both these types of fabrics. And the important part is that they do protect us in the end. And we'll look now at some fibers and their advantages and disadvantages and how they are mixed to create FR fabrics.
Good. Just before we go there, Tara, let's ask our first and only interactive question of the day. So, after I've finished giving you the possible answers, you'll be able to vote on your screen. So we want to know what is the main obstacle you're facing with your current safety program? Is it that A, employees do not want to wear their FR/AR clothing because of discomfort, because it's too hot, because of the lack of mobility? Or B, their clothing is not identified FR and AR, therefore compliance management is difficult? Is it C, the lack of knowledge in terms of FR, AR categories? Is it D, all of the above? Or is it E, other reasons? We'll give you a few seconds to answer. You may pick one amongst these possible answers. Do, 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 do. Okay, people are voting. Good. Interesting. All right. So we can see I'm really happy that nobody no no employees do not want to wear their FR/AR clothing. That's a good that's
Very
a good
good.
point. But still, I think the most obstacle is the lack of knowledge in terms of FR/AR categories, which we'll talk about in the upcoming slides. Some of them also are the clothing is not identified, so therefore compliance is difficult. So very interesting. Thanks, folks, for participating in that quick poll question. So then moving on with the presentation, I think that the process is not what's really important when we talk about FR/AR fabrics, but the properties of the actual fabrics.
Yes, that's right. So, I mean, whether inherent or treated, all FR fabrics are engineered using science. So, an FR fabric doesn't exist in nature. So, there's three ways in which FR properties can be imparted to a fabric. So, when we talk about aramids, like your Nomexes, your Kevlars, fibers are altered at the molecular level. For Modacrylic blends, like our TecaSafe, the fire retardant chemicals are added during the actual spinning of the fibers. And then lastly, when we talk about our cotton blends, like our Ultrasoft 8812s, fire retardant chemistry and mechanical processes are used to permanently bond the FR chemistry to the fabrics. So when we talk about FR properties, we mean that the fabric will self-extinguish when the ignition source is removed, and all three of these can achieve that result.
Just before we move to the next slide, Tara, if I go back to the previous slide, I just wanted to mention some people are writing to me personally mentioning the answer is E, others. If you want to share what other obstacle you're facing, you're welcome to do so in our survey at the end. There will be a comments question, so you may just answer, give us your the detail of your main obstacle if you want to. I'll let you move on with the strengths and weaknesses of the common fibers found in the FR market.
Okay, so here are some of the most common fibers found in the FR market. We have Aramid cotton, lyocell, nylon, and Modacrylic. I'm sure many of you, of course, have heard of these fibers. Many of our fabrics are made of a blend of these fabrics, so we'll consider each one individually in the upcoming slides and kind of take a look of their strengths and weaknesses.
Good. So let's start with Aramid fiber.
So Aramid, some of the brand names you hear are Nomex, Conex, Kevlar,
Carmel.
exactly. So basically what aramids are, they are high melting and largely insoluble molecules that are ideal for spinning into high performance fibers. So when we think of aramid blends, we think of good thermal stability, high strength, and superior toughness and durability. Weaknesses are unfortunately poor moisture wicking. They're pretty high in price and they're difficult to dye, meaning that we can't get them in every shade.
Here's a funny story, guys. You see on your screen, it's a French slide. Well, in the previous French webinar, we had the English slide on that slide. So might as well laugh about it. And that's the life of the direct, guys. So sorry about that. Let's move on to the next one. So cotton and lyocell. Some people actually, Tara, are surprised to learn that lyocell is non-FR, right?
Correct. It's actually a form of rayon, and we see this with lyocell and with nylon that we use both to integrate with cotton. It's used in a percentage where, although it is non-FR, the actual finished fabric is still compliant. Cotton lyocell's strengths are definitely that they're easy to dye. You could pretty much dye them in any color you could think of. Very comfortable. Um, Great wicking performance. Cotton will dry very quickly, and the price is relatively low. The weaknesses, like we said, they're generally non-FR fibers. They're relatively weak, meaning they can tear easily and they lack durability.
All right. When talking about nylon.
So nylon, why do we add nylon? We see it a lot in our ultra soft, like I discussed, our 8812 fabrics, which are 88% cotton, 12% nylon. So nylon is added as a high tenacity fabric, meaning it adds a lot of strength to the cotton, where we know from the previous slide, we said cotton is relatively weak. So the nylon does add strength. Again, easy to dye and relatively low in price. Weaknesses, again, is that nylon is non-FR. It is meltable before being mixed with our treated cotton, and some perceive it to be uncomfortable.
Okay, so Modacrylic.
So our Modacrylic, it's a very nice fabric because we're able to use a lighter fabric but achieve a higher protection level. So most of our monocrylic blends do meet at least category 2, but using a lighter weight fabric than we have to use with most other fabrics. Again, it's easy to dye. It's very durable. The price is also relatively low. It will definitely be more than our cotton blends, and it's inherently flame resistant. One of the greatest weaknesses of monocrylic is its propensity to shrink when exposed to high heat. So um, definitely consider that when using monocrylic blends, that there will be shrinkage after wash. And again, some perceive it to be uncomfortable.
Okay, so one of the questions that we were asking us today is what makes up an arc rating? Can you explain that and then maybe explain the categories after?
Sure. So sure many of you being wearers of FR clothing have seen this chart before. Um, Basically, arc ratings are defined in calories over centimeters squared. So 1 calorie of energy is equivalent to holding a lighter up to your finger for 1 second. I'm not sure if any of you have heard that before, but if you feel free to test it after this webinar and let me know how that goes. But essentially, you'll see that 1 calorie is still quite painful. So we have this chart which explains the calories and what category they refer to. Category 1 is something you'll find mostly, we'll say, in the oil and gas industry, refineries, where it's not so much an electrical hazard, but more of a flash fire hazard. So it's an FR shirt or pant or an FR coverall, so 1 layer of FR clothing, and that's from 4 up to 7.9 calories. Category 2 is what 90% of our arc flash wearers will be in. It's category 2 is a garment that you'll be wearing all day long when you're in an environment where an arc flash hazard may exist. So you need an FR shirt and pant or FR coverall. And of course, 100% cotton for your undergarments. Important to note that is part of the standard, the CSA standard. We never want to be wearing polyester, which can melt and stick to the skin if there is an electric arc explosion. Category 3, you can think of as your FR Arc Flash Parka or winter coat. It has 2 layers of FR fabric, so your outer shell will be FR, your insulation will be FR, and then of course you're wearing your FR coverall or pant and shirt combo under, and always your cotton, 100% cotton undergarments. Category 4 is a very specialized, what we call a Cat 4 suit. Category 4 is, sorry, 40 cal suit. So it would be 40 cals and over, category 4, and that is your big arc flash suit that you'll put on when you're working on a breaker. It's not something that you're going to wear all day long.
It's more for specialized tasks or
Exactly, high voltage
yeah,
tasks.
high voltage. All right. So injuries can be caused by electric arc explosion, which is the video we're going to see. Don't worry if you do not hear anything. It's not meant to have any sound or anything. I think the image will speak for itself. You don't need to hear anything. So bear with us for a moment. We'll start the video. All right. So as I said, the image speaks for itself. Did he survive? Do you know?
He did survive because he did have his arc flash clothing on. Um, I mean, this is very scary, as you could see. Just you could imagine there was no sound here. We didn't want to blow out your eardrums, but the immense sound and light and particles flying in the air. So, I mean, I'm sure the video kind of drove it home, but to reiterate the common injuries that you can sustain from an electric arc explosion, number one, there's blindness from the blinding white light. There's deafness from the loud noise, which can come in at 165 decibels. Of course, burns from the electric current flowing through the ionized air, which can reach temperatures of up to 35,000 degrees.
Whew.
And lastly, a physical trauma from the shock wave that can rupture eardrums, collapse lungs, and cause fatal injuries.
Yep. I think that you better protect yourself.
Correct.
So the next video that we have shows the fabric, basically one FR versus the other one non-FR. So again, no sound, just image. So bear with me. We'll start the video. So as you can see, I would rather wear the clothing on the right side.
Yes, I agree with that. So, I mean, I think the video is pretty self-explanatory. We see the mannequin on the right is wearing an FR shirt, which has very quickly self-extinguished, while the mannequin on the left is not wearing an FR shirt, and the fabric continues to burn and it quickly breaks open, exposing the skin. So, safe to say that there will be second, even third degree burns.
Yeah, no kidding. All right. So let's talk about the CSA standard. So what does the CSA Z462 really requires from a clothing manufacturer?
So CSA Z462 is the general standard for arc flash clothing. So CSA Z462 requires that clothing meets the specifications which are set out by ASTM 1506. Now, ASTM 1506 specifies basically the design and fabrication and test methods for flame resistant materials worn by electrical workers. We use two tests. One is a flammability test and one is an arc rating test. And we'll take a look at these in the upcoming slides.
Okay. So maybe we can start with the video that shows the test method for flame resistance of textile. So again, no sound. And let's start the video.
Ready? Ready?
All right. So maybe Tara, you can explain the test, what exactly
Absolutely.
they did.
So this is the flammability test. It's called ASTM D6413, and it's a test method for flame resistance of the textiles. So some of you may have heard of this. It's called the vertical flame test. So it determines whether a fabric will continue to burn after the source of ignition is removed. So basically, they take a 12-inch piece of fabric, it's suspended in an enclosed chamber and is exposed to a controlled methane flame for 12 seconds. Um, we want basically a pass or fail criteria, and it requires a maximum char length of 6 inches. We see here that our fabric extinguished quite quickly, and it definitely passed the test.
Good. So the second test for the test method for arc rating of textile.
So ASTM F1959 takes it one step further. So we've established in the preceding test the flame resistance of our fabric, but now we are trying to establish, categorize its arc rating. So this test is used to determine how much heat a fabric will block from an electric arc before causing second-degree burns. Um, we use an instrument called a calorimeter, which measures the heat transfer through the fabric, and then it gets assigned its category and calorie rating, which is known as the arc rating of the garment.
All right. So I think it's safe to say that the perfect fiber does not exist, right?
That's correct. I mean, we haven't reached a level of perfection yet in the industry. As a manufacturer, we're always looking for the next winning fabric, and we have the opportunity, thankfully, to evaluate all viable FR fabrics. What we want to do is find a perfect combo of durability, comfort, a light garment. I mean, everything a wearer is looking for, and I don't think we've gotten there yet, but we do have some great options in the FR world. I mean, the most important is that the FR engineering of the garment is accomplished in a way that it can be guaranteed for the life of the garment.
All right. So, and Tara, Bulwark innovates year after year. So this year, Bulwark came up with the IQ Endurance
Yeah, so
clothing.
this is an example of innovation in the FR fabric world. We've come a long way since, the days of Nomex being the only flame resistant fabric. We started experimenting more and more with perhaps more comfortable fabrics, or how can we make it lighter. We went into cotton blends, cotton nylon. So now with IQ, we've been able to add polyester to an FR garment, and you still have the same guarantee of flame resistant protection for the life of the garment. We all know polyester to be a performance fabric used in a lot of dry fit clothing. So take that idea and apply it to FR. You have a light garment which breathes, which facilitates movement, which retains color, and which is quite durable. So again, fabrics keep getting better and better as more research is done.
Good. It's time for questions. And if you have questions or anything you want to bring up, we do have one already. If we go back to the video, I'll move back to the video. I won't show the video, but when talking about this, Tara, what about FR undergarment as a second layer, like 70% Modacrylic, 30% cotton to achieve a category 2 or 3?
That's a great question. I love layering. Sometimes it's more comfortable to layer two lightweight pieces instead of having one heavier piece. Um, Again, it's that you sometimes need the help of your manufacturer or supplier to understand exactly what you can layer. So keep in mind that it's not simply adding the calories of two garments and putting them together. You actually do have to test it as a system. We have a tool on the Bulwark site, which is a arc rating calculator. Any of your SPI representatives could also help you with this. But that's a great question, and layering is definitely a very plausible option.
Good. We have another question. Is it true you can't wear polyester as it could melt?
Correct. So I know it's a bit confusing. I said no polyester, and then I showed you a garment at the end that has polyester in it. Keep in mind that the polyester that we use in our IQ garments is a treated polyester. So the same way you may treat a cotton in phosphorus and ammonia, we've treated our polyester so that it's flame resistant. Now, regular everyday polyester, like can you put on a Nike dry fit shirt? No, because it will melt to your skin and will actually increase the injury. You're better off having nothing on than having polyester on.
Wow. Okay. Another question, is there any specific ways that we can wash the FR clothing or
The main rules, and you'll hear most manufacturers drill this into your heads: never use bleach, never use fabric softener. These are two chemicals that could definitely interrupt the FR properties. Um, Other than that, you're pretty safe to home wash. Of course, it all depends what kind of chemicals might be on your garments. You may not want to throw it in with your other garments, but I would say to be safe, you should always ask your supplier to provide washing instructions. But again, keep in mind two general rules are no bleach and no fabric softener.
and if I can add, last year we did a webinar where we discussed the maintenance of the clothing. So I invite you to go on SPI's YouTube channel. You'll be able to find that webinar on electrical safety. And Tara had a few slides
Mm-hmm.
about how do we take care of the maintenance of our clothing. Um, mm, One last question before we finish. How long does FR clothing can last, provided good washing practices?
There's definitely not a general answer. Of course, we went through the different fibers and fabrics that make up FR garments, and there's definitely different shelf life for each and every fabric on the market. Different price points equal different life cycles and durability. So I can't give you an exact answer when we talk about per fabric. I mean, obviously, you're going to have your cottons being the least durable and your aramids like Nomex being the most durable, if I can give a general answer, and everything else kind of in between. If you want to send an individual question after Amelie about what fabrics you're wearing specifically, I could give you a more specific answer.
Good. I lied. One very last question. I just think it's very interesting. Clay is asking, is there a chart that shows how many calories versus volts? For example, need protective garments for 600 volts.
Good question. Um, there is no chart because there's different variables. So when you have your hazard risk analysis, that's something that the expert of, let's say, the CNESST would let you know. The reason being is because it really depends the distance and the environment. So it's not solely based on voltage. I'm personally not an expert in that domain, but there are different variables. So it wouldn't solely be based on the voltage of the equipment.
All right. Thanks, Tara. Just before we end this webinar, just want to let you know that SPI has launched its new website 2 weeks ago. Simple, fast, easy to use, more efficient. You can see the history of your orders. Well, we invite you to visit it. It's really sharp. We worked very hard on it. You'll find our blog as well with very informative articles. Some are from actually Bulwark, who's participated in creating those. We also have our tab, the events tab, so you can see what's coming up. Obviously, nothing is coming up for now because it's the end of the the end of the year, and we're planning our program for next year. But I invite you to visit our new website. Obviously, I invite you to visit our Facebook and LinkedIn accounts as well. So thank you very much, Tara, for this very interesting presentation.
Thank you so much, everyone.
Thanks all for your participation. As I mentioned, we're taking some time off for the holiday season. We'll be back in March 2020, so stay tuned. We'll send you an email and we'll publish it on our social media. Um, as I mentioned at the beginning, please fill out our survey. It's very important for us to know how we did and how we can improve, but also to figure out what are your needs in terms of OH&S risks. That allows us to give you free webinars such the one that you've participated today. So on behalf of myself, SPI, Bulwark, wish you a great holiday season. Be safe. Talk to you soon.